Hello, I'm Ryan. I am the Technical Support Manager for MidNite Solar. My experience: I have been a licensed electrician for over 20 years. I've been installing renewable energy gear for over 10 years, specializing in off-grid systems. I enjoy building wind turbines and anything else mechanical, basically. I've been a licensed general class amateur radio operator for a couple of years now, and I got my start at 6 years old wiring motors together on my mom's kitchen counter and testing the ability of her fuse box to protect the wiring in the house as well as the little ones doing the experiment. MPPT charge controllers. Which controller should you choose? We're going to help make that decision easier. The MidNite Classic. 6 years in the making, the world's most sophisticated MPPT charge controller. The MidNite Classic features. The Classic incorporates things we have learned by producing tons of controllers over our years in the industry. The Classic MPPT works for wind, solar, hydro, and alternative DC inputs as well. The world's only arc fault detecting controller. Classic has built-in ground fault protection, saving you time, space, and money. HyperVOC extends cold temperature VOC capability of the controller. Ethernet, USB, RS-232 interfaces, as well as the published Modbus Protocol. 2 auxiliary outputs, one can be configured as an input. High voltage versions available. We have 150 volt, 200 volt, and 250 volt operational limits, and can charge from a 12 to a 120 volt nominal battery bank. Wizard driven setup ensuring compatible module mix. Simple to use, upgradable firmware. Graphical display versus alphanumeric display. Classic stores 380 days of data on board. Graphs of data available on the display on the Classic as well as on your PC over the internet. Ethernet for easy hookup to the internet. Voice is being added to the display in the summer of 2012. And the display can be relocated. The Classic is available in several models with input voltages of 150, 200, and 250. It models to charge up to a 120 volt nominal battery bank. As you can see, we operate above the 150 volt rating of standard controllers. This picture is showing an operating voltage of 228.8 volts DC. This brings up the need for high voltage breakers on the PV side of the Classic. MidNite has breakers rated for 300 volts DC in DIN rail mount as well as panel mount to accommodate this requirement in the combiner boxes as well as on the input to the Classic. It is important to use DC rated breakers that are rated for the voltage they'll be working at. If breakers with the incorrect ratings are used, the risk of fire from the breaker's lack of being able to extinguish the high voltage DC arc will be a possibility. We recommend our 300 volt versions of our MNE DC or MNE PV breakers for the input of the Classic 200 or 250. Introducing the Classic Lite. The Classic Lite models are the same as the regular Classics, except for the removal of the display and arc fault. They will retail for about $150 less than their standard model counterpart. They have dip switch programming and LED indicators for bulk, absorb, float, and EQ, as well as a manual EQ button. They have the full internet and network capability of their full-featured versions, so access and programming these over the PC is easily achieved. These models will be perfect for installs requiring multiple Classics, as well as installs where the display is not needed or required. My test site in Maine. This is my off-grid power system, and as you can see, we have 3 different solar controllers installed as well as an APRS World data logger. We have 3 identical arrays made up of 6 Solar World 165s each. This gave us the ability to do side-by-side testing with third-party data logging. We also switched arrays around regularly to account for differences in panels. We found some very interesting results. The Classic would routinely harvest more kilowatt hours per day than the competition. Some were a lot less productive than others, and there were a couple real eye-openers. We always knew the MX60 was good, but we were surprised to find it outperformed the FM60 daily. We used to get beat up a lot over the MX60 and now the FM60, reading higher on the display for output than it really was. And not wanting to make that mistake again, we installed shunts internally on the input and output of the Classic so the display is highly accurate. This has caused a few interesting phone calls from customers of MX60s or other brands of controllers that were reading up to 10% higher than reality, and they swapped in the Classic and got the real numbers, and then called us to ask us why the difference. And once we explained that, it would become rather interesting. Because I have an interest in everything mechanical, I've always been tasked with pushing things way beyond the limit with the Classic. In the early days of R&D on the Classic, there were no current limits, etc. So I got to push things beyond the limit to see what happens. Due to this, I had a lot of spectacular failures of Classic controllers. This prompted Tom to recommend a special add-on feature for my Classics. Rumor has it I've broken more Classics than everyone else combined. What can I say? They asked me to find where the limits were, and I did. A variety of tracking algorithms. The Classic has a variety of different tracking algorithms, or modes. These are modes for solar, wind, hydro for starters, as well as use set mode where you can park at a percentage of VOC, as well as a few other modes that can be useful for other inputs as well. These modes all have a variety of settings that the user can adjust to tweak the controller to exactly match their DC source device. More daily harvest than the competition. What we're looking at here is a 7-day screen capture of data provided by APRS World. You're looking at data from a MidNite Classic 150, an Outback FM60, and a Xantrex XW60 MPPT. This is 7 days of data, real live data collected off in 3 identical arrays of Solar World panels. The arrays were calibrated for the purpose of this testing that we did. We did this testing for probably about 2 years in the early days of the Classic, and we tested a lot of the other competition too. We just didn't have room on the screen for that data. As you can see, the Classic routinely harvests 2 to 3, 5%, sometimes even up to 10% more than the competition, just basically by having a superior tracking algorithm. Here we show the power curves for the Classic 150 and 200 models. We were able to make a sliding current limit for the Classic. As you can see, the output current limit is based on battery voltage as well as input voltage. The wider the separation is between input voltage and battery voltage, the more heat we put into the components. This is going to be true of any MPPT charge controller, not just the Classic. We usually want to design around the Classic 150 and an input voltage that is 1 nominal voltage above the battery. For example, a 48 volt array would be best suited on a 24 volt battery. There are, of course, exceptions to this, and long wire runs or high voltage panels often dictate that we use the higher voltage Classic. An example would be a 48 volt battery system where the wire run from the PV to the Classic is 300 feet long. To save some money on copper, we could go to a Classic 250 and a higher voltage array. The very slight loss in efficiency is more than made up for in savings in copper. There's also going to be times with wind or hydro where the device will dictate what Classic to use. An example of this would be the new Berge XL1 wind turbine that was designed to work with a Classic 250 and does not require a clipper. Here we're showing the same power curves, but for the Classic 250 and the 250 KS. The standard Classic models will charge from 12 to 72 volt nominal battery banks, and the 250 Kangaroo Special will charge from 12 to 120 volt nominal battery banks. MPPT for wind. MPPT can greatly enhance the function of wind turbines as well. The typical installation of a wind turbine has the turbine wired directly to the batteries and a diversion controller off the batteries. The problem with this, as shown in the graph, is the turbine's RPMs are then held down by the battery voltage. The turbine's blades are designed to run at a ratio proportional to wind speed. This is called TSR, or tip speed ratio. When hooked to the battery, the turbine will only be at its optimal TSR at 1 wind speed and effectively stalled above that speed. It's basically like driving a car down the road with the gas all the way to the floor and using the brakes to regulate the speed of the car, so to speak. With MPPT, we allow the turbine voltage to rise with wind speed, keeping the turbine at its optimum TSR at any wind speed. This will result in a large gain in power. We've routinely seen from 2 to 3 times the productivity from most turbines. The Classic uses a 16-point power curve that can the user can adjust for their particular turbine. We also have preset power curves for a lot of the popular wind turbines pre-programmed in, and we'll continue to add these as they are supplied to us by the manufacturer. In the future, there'll also be a wind learn mode that will take a starting curve and adapt it to your particular site. It will actually learn your turbine and learn what the most efficient curve for your turbine is. Basically, always be looking around and tweaking just a little bit to make sure that it's being as productive as possible. The MidNite Clipper. I want to briefly mention the MidNite Clipper. This is a protective device that goes between your hydro or wind and the Classic. It has its own fail-safe circuitry that is powered from the turbine and will limit maximum open circuit voltage. It also communicates with the Classic. The Classic will tell the Clipper when the batteries are getting full, and it will slow down the turbine a little at a time as needed to maintain the charge stage voltage it is targeting. This will allow regular 3-stage charging, just as we do with PV, and also reduce wear and tear on the turbine. We have even had one customer who had a turbine that was too noisy for his neighbor, so he used a clipper to limit the turbine's max speed, allowing the turbine to run quieter and keep a happy relationship with his neighbor. Arc fault protection. Arc fault protection is now required by the NEC, and we're the only manufacturer in the world to have this in their charge controller. The Classic comes standard with arc fault in all models except the Lite. This makes for a safer installation as well as a code compliant installation. The arc fault in the Classic is fully adjustable for sensitivity, and the Classic will also be able to work in conjunction with our disconnecting combiners to shut off the combiner upon detection of an arc fault. Ground fault protection is a built-in feature on the Classic charge controller. This will save you between $69 to $119 depending on what model of GFP you would have needed. It also simplifies the installation and saves space in the E-panel for other breakers. HyperVOC. HyperVOC is a unique feature in the Classic. It is a non-operational safety zone for those record cold mornings. You can see here this is a record cold morning and the PV voltage has climbed around 170 volts DC on the Classic 150. The Classic simply stays in resting until the sun warms the panels and drops the voltage to 150 volts DC, and at that time the Classic turns on and operates normally. As you can see in this slide, the HyperVOC voltage limit changes based on the battery voltage. So for a Classic 150 on a 12 volt battery, we have 162 volt DC as a safe max VOC. On a 24 volt battery it would be 174 volts DC, and on a 48 volt and above the maximum VOC is 198 volts DC. This needs to be considered when designing the system, and it allows you to design the system around the normal cold, not the record cold. Care does need to be taken though not to abuse HyperVOC, otherwise the Classic may spend a lot of time in resting. Communications. Communications was something we felt was important on the Classic, so we included RS-232, USB, and Ethernet on board. We also used a Modbus Protocol that we publish, so anyone can talk to their Classic or monitor their Classic. Here you see a screenshot of a communications program APRS World has designed to work with their Classic as well as other devices at the same time. MidNite also has free software that allows the user to work with their Classic over their local network or over the internet. We'll talk more about that later. Auxiliary relays. The Classic has 2 auxiliary outputs as standard equipment, giving you more options for control of your system. Auxiliary 1 can be set up as a 12 volt DC signal, good for 200 milliamps, or a relay contact, good for 1 amp. Auxiliary 2 can be set up as a 12 volt DC signal, also good for 200 milliamps, or as a 0 to 3 volt input signal. There are basic on and off functions, as well as PWM functions for driving solid-state relays for a more elegant load diversion. This is a current list of auxiliary functions found in the Classic. Vent fan low and vent fan high modes are designed to turn on a vent fan at a user-adjustable battery voltage. Float low and float high. Float low is active when the Classic is not in float, and float high is active when the Classic is in float. Clipper control was designed to control the MidNite Clipper for wind or hydro. Daylight is active during the times when input voltage is above the battery voltage. Nightlight is active during the times when input voltage is below the battery voltage, and we will be adding a timer to these as well to allow the light to be turned off after so many hours of runtime. Toggle test is a basic 1 second on, 1 second off, toggle back and forth mode. Pretty useful for testing stuff. Once you've got your relays all wired up, you can put it in toggle test to make sure everything's working the way you want it. PV voltage on low. This will be active below an input voltage that's user adjustable. PV voltage on high will be active above an input voltage that's also user adjustable. Waste not high will divert any unneeded power available while maintaining the voltage set point of the current charge state. Low battery disconnect will become active below a battery voltage that's user adjustable. And diversion will become active above a battery voltage that's user adjustable. And most of these modes as well have a delay and a hold time that's adjustable as well, so that you can stop relays from clicking off and on rapidly. For instance, diversion with the manual relay, if it's a big load, the minute it kicks in, it could drag the battery voltage down. So we've put a delay and a hold. So we wait for however many seconds or minutes that you program, and then we also hold the relay on as a delay for however long you've programmed it as well. The wizard. The Classic has a built-in setup wizard that walks the user through setup with simple to answer questions. It checks things like the PV array to determine that it's inside the operational window of the Classic, as well as checking things like the voltage drop on the PV wiring. It will also provide you with the appropriate combiner box and overcurrent recommendations as well. The same wizard is also available on our website to assist in pre-purchase system design. Simple firmware upgrades. The Classic has a simple-to-use firmware upgrade interface that runs on a Windows-based PC. It's a user-friendly process. We have also made sure that if the wrong firmware is installed in the Classic, it'll tell you so and you simply install the correct firmware. Or if the firmware installation is interrupted for some reason, laptop battery goes dead, dog unplugs a cable, whatever the case may be, no harm is done, just simply install the firmware again. Makes adding new features to the Classic easy in the field as they're released. And the firmware upgrades will always be available on our website for no cost to every Classic owner for the life of the Classic. LED modes. The Classic has several LED indicators that can be programmed to tell us different stuff. Off mode, no LED activity period, no matter what. Rick mode. Rick was a gentleman in Hawaii who does not like blinking lights, so we named it after Rick, and Rick mode is errors only. Only things like arc fault or ground fault will give you any LED indication. LED 1 mode will give you indication of auxiliary 1 or auxiliary 2 being active, give you all errors and all warnings, as well as a green float indicator. Blinky mode. Blinky mode cycles the LEDs around in a loop. Really useful if you're going to have a disco or a party or something. Audio. The Classic is unique. It will have the ability to speak to you. We will of course have several levels of function to this, including off. The Classic will be able to speak help screens to you as well as numerous other things. And knowing the engineers in charge of this product, I suspect a mode that will also be very entertaining. Data logging and graphing. The Classic logs 380 days of data in its daily logs. The Classic also logs data every 5 minutes in its recent logs, allowing you to view the last 24 hours of history. The Classic also has the ability to draw graphs on its screen of this log data. Remote monitoring. MidNite offers a couple ways to monitor your Classic remotely. The local app is a software program that we give away that runs on your PC. This was designed originally for the local network, but works fine over the internet with a little programming in your router. We also have My MidNite, which is a web-based version. This version is also free and is hosted on our server. This version allows the user to check their Classic over the internet from any PC in the world with just a username and password. Our software is a little unique in that it has a retro classy look to it, and we will in time offer different skins to allow the user to tailor the look to their own personality. Both the local app and My MidNite offer full two-way communications, allowing users to make changes to the Classic from away if so desired. Password protection will be standard, and there will also be a hardware jumper internally on the Classic to disable all writing to the Classic. Here is just one example of the graphing available with our software. This is showing a 30-minute block of data in a line graph. The software can graph any data the Classic is logging. The local app only logs when it's actually running, but it will pull the Classic for missing data every time it connects. My MidNite receives data every 5 minutes and logs that onto the server for future use. To draw graphs on the local app or on my MidNite, we basically have to left-click on the Data tab and left-click on the Charts tab as shown. Now you'll notice there's no data available on the chart, and that's because we haven't selected any values to chart yet. So now we need to left-click on the values to chart. And now we need to left-click a checkbox for each value we would like to chart. In this case, you'll notice we've checked battery voltage and watts, and then we left-click on the X. Now you'll see we need to select a few other items. We need to select the day, the date of the data we want to look at by using the calendar. We need to select the amount of data we want to see. In this case, we have a half hour selected. And as you can see down bottom, we can select which style of graph we'd like to look at. In this case, we selected line. And that's about it for graphing. Then you can actually scroll left or right in the time. You'll notice there's a right arrow over there that's highlighted. The left arrow is not. What that's telling us is there is no data previously to that timestamp where the data starts. So that app was just starting to log data at that point. You can scroll back and forth through the time with those arrows. Also, you'll notice there's an export button. The data that's saved in the app can actually be exported as a CSV file. This can be then brought into Excel and manipulated any way you prefer. In here we're looking at just another screenshot of a graph. This is a 24-hour period of data on a 3 kilowatt solar array. You'll notice that the sun came up and the wattage gently came up and peaked there at about 2,600 watts or so. You also notice that as in the afternoon there must have been a little clouding event that came along because the wattage dropped off a little sharply there in the afternoon. And you can see around 1,500 hours it kind of opened back up and ramped back down. So we're looking at a 24-hour block of data, and as we talked before, this can be selected from a day. We could drop that down to a half an hour, an hour. We can also scroll back and forth through that data and look at it. Here we're looking at just another graphing option. This is a bar graph, and as you can see, we're doing battery voltage, input voltage, and kilowatt hours. This is a day's worth of data as well, and you notice how they all three coincide on the screen together and in reference to what they are. Here we're looking at an example of our two-way communications. This shows how we can change the name of the Classic as well as its port number. It also shows auxiliary 1 and auxiliary 2 functions, giving us the ability to manipulate things from away. Battery temperature compensation. The Classic has adjustable temperature compensation that can be adjusted from 0 to -10 millivolts per degree C per cell in 0.5 millivolt increments. There are also minimum and maximum voltage set points that the Classic will stay within when compensating for battery temperature. Equalize functions. The Classic has a manual equalize mode as well as an auto equalize mode. Manual EQ will basically stay in EQ for the day. When it goes to resting at night, and the next morning when it wakes up, it will not be in EQ anymore. Auto EQ has days you can adjust between equalized charges. So you can set it for 30 days between equalized charges or 60 days between equalized charges, example. It also has days to retry, which is a little unique. And basically what this does is it's adjustable from 0, which means it will not retry for a second day, or it can be adjusted all the way up to the days between equalized charges that you set in the previous step, meaning that it will stay in EQ until it actually completes or the next interval comes up. Basically, it's just allowing you to decide what happens if the EQ charge failed on the first day to complete. For example, say we have intervals set to 30 days between EQ charges, and we have retry days set to 2. The Classic will attempt to EQ charge every 30 days. If it does not complete one on the first day, it will try for 2 more complete days and then give up until the next scheduled interval. Picture of Solarfest in Vermont, 2011. These 4 Classics are charging a large battery bank behind the wall. powering a very large array of Outback inverters, and they're running the lights and the sound stage for the music at Solarfest. Here we see a picture of 8 Classics installed on a custom-built rack by the Solar Stone. This rack also houses 7 Outback Radiant inverters and is powering a telecom site. The MidNite Solar Forum. MidNite Solar has a forum on their website. You can go to www.midnitesolar.com, click on the forum tab, and it will bring you to our forum. We have categories for pretty much every product we make. And you'll notice we also have FAQs in each category. So if there's any questions on our products, chances are you may find answers there already. If not, feel free to call us. Feel free to post them on there. We have several employees that monitor this forum on a regular basis. We also have several very helpful installers and end users out there that participate in this forum on a very regular basis, and just a wealth of knowledge, and we hope that it continues to grow from there. And there's also a fun side to it. We have a category called Reg Chew, where we put up just about anything we feel like talking about, and we welcome everybody to participate, and hope to see you there. MidNite Solar has begun producing instructional videos on our products. These videos are intended to help you understand the proper use of our product, as well as the installation process of our product, and just general information on our products. These videos can be found at our website, www.midnitesolar.com. You'll see them on the left-hand side of the homepage. There's several of them up there now. They're also linked in our price list, or when you go to our products, the videos for that product will actually be linked with that product. So we encourage you to go check them out and enjoy them. These videos are done with our own employees, so they can get quite humorous at times. So sit back, enjoy, and have fun. And here's the Mid Nite Cat. MidNite's a cat that she showed up at the facilities shortly after we took possession of the building, and has been with us ever since, and loves to help build combiner boxes. So if you ever find cat hair in your combiner box, you can blame MidNite for that one.